example 5. Show that quadrilateral ABCD is a parallelogram. Now, in order to do that, if you go back up to your second slide, we have 5 different ways of doing that. So if I go back real quick, we can show that both pairs of opposite sides are parallel. We can show that both pairs of opposite sides are congruent. We can show that both pairs of opposite angles are congruent. We can show that one pair of opposite sides are congruent and parallel, or we can show that the diagonals bisect each other. Now, if I'm looking at the sides, proving that these are going to be the same length is going to require the distance formula. That's too much work. I don't want to do it. Proving that these angles are congruent is going to require some sort of math on a grid that I don't even know of right now, so I'm not going to do that. Proving that the diagonals bisect each other, first of all, would require me to find the diagonals and then prove that they bisect each other. So I don't want to do any of that either. The easiest method here is going to be proving that these are parallel. And the way you do that is you find the slope. Okay? So slope, remember, is rise over run. So I'm going to start at A, and I'm going to try to get to B, and I'm going to rise 1, 2, and I'm going to run 1, 2, 3, 4, 5. So I know that the slope of A to B is 2/5. Now I'm going to use that information, and I'm going to go down here, and I'm going to do D to C. Rise 1, 2, run 1, 2, 3, 4, 5. So these two are parallel. They have the same slope. So far, so good. Now, I'm going to do DA, rise 1, 2, 3, run 1, 2, 3. And notice that that's like backwards 3. So 3 over backwards 3 is -1. Then I'm going to do CB, rise 1, 2, 3, backwards 1, 2, 3. 3 over -3, also -1. So these are parallel. So it says show that it's a parallelogram. Well, right here, you have showed that it's a parallelogram because you have shown that opposite sides are parallel, which is by the definition of a parallelogram, which is number 1 on your chart.